This video is on solving absolute value equations. The first thing we have to make sure that you know how to do is, or that you know, is to understand what the absolute value of something means. The definition of absolute value is the distance away from zero. So when we say the absolute value of negative 10 equals 10, that's because, why isn't this focusing? That's because the absolute value, negative 10 is 10 units away from 10. Hold on. That's not what I wanted to do. Where is the focus? Okay, so that's why the absolute value of negative 10 is 10. The absolute value of x minus 5, we want to equal 12. Now remember, we don't know what x is, but we know that we want this expression to be 12 units away from 0. Well, if it's at positive 12, then it's 12 units away from 0. But if it's at negative 12, it's also at 12 units away from 0. So we're going to write two separate equations showing that this expression could be at one of two different places. Now let me tell you a very common mistake. People always say to me, well, my teacher said you can't have a negative in the absolute value. So they changed this minus to a plus. That is absolutely not how this should be happening. What we're saying is this whole expression, x minus 5, needs to be 12 units away from 0. So you never, ever, 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 ever change what's in here. You only ever change what's out here. So now when I solve these two equations, you can see that x equals negative 7 and x equals 17. And the reason is when you plug in negative 7 here, negative 7 minus 5 is negative 12, and the absolute value of negative 12 is 12. And when x is 17, 17 minus 5 is 12, the absolute value of 12 is 12. This absolute value equation has two solutions. Now we're also going to take a look at it on the graphing calculator and remind you how to solve equations on the graphing calculator. Now I went into y equals and I put in the absolute value of x minus 5 by doing math num abs, and I put x minus 5 in there, and then I put, I should show you, I did math, arrowed over to num, and then hit enter for abs. Then in y2 I just put 12. So when I look at the graph, wherever the red and the blue cross, it's going to be the solutions to my equation. So you can see it crosses in two places, and to figure out what those are, we do second, calc, intersect, and then we push enter for the first curve, enter for the second curve, and yes, we would like to guess, so 3 enters, and you can see that when x equals negative 7, y equals 12. Now, the y obviously equals 12. That's what you're saying. I want to know when this equals 12. When x is negative 7, this is 12. So when I go figure out what this point of intersection is, the y value here is also going to be 12. Also remember, this red line represents y equals 12. It's a horizontal line, and every single y value on this line is 12. So I'm going to go second calc intersect again. This is just a reminder of how to solve on a graphing calculator. And I'm going to arrow over closer to the other intersection. I do not have to be on it. I just have to be closer to it. Tell the calculator, find me the intersection that's closer to my cursor. So I'm going to push enter, get to the second curve, push enter again, and then push enter again. And the intersection here is, should be 17. I don't know why we're freezing. Come on, man. Apparently this doesn't want to work with this program, which means I'm not going to use this program anymore. Alright, we're done with that. Let's solve another absolute value equation. How about the absolute value of 35 minus 5x equals 10? Again, this expression is either going to be at negative 10 or positive 10. So we write two separate equations. And we subtract 35 from both sides. So now you have negative 5x equals negative 45. Divide by negative 5 and x equals 9. minus 35 from both sides, so negative 5x equals negative 25. Divide by negative 5, and x equals positive 5. Now this is a good one to check on the calculator because you did a lot of negatives and you just want to make sure you didn't mess it up. So if my graphing calculator program wasn't frozen, I would show you, but it is, so I can't. Okay, we're going to do one more of these. One that has a couple extra steps in it. So 2x minus 5 plus 3 equals 14. Okay? Now, you're going to say, well, you just said put it negative, put it positive, and solve. But you must isolate the absolute value first. So the first thing I'm going to do is get the absolute value by itself by subtracting 3 from both sides. Now I can write my two equations. 2x minus 5 equals 11. 2x minus 5 equals negative 11. Add 5. 2x equals 16. Divide by 2, and x equals 8. Add 5. 2x equals negative 6. Divide by 2, and x equals negative 3. And if you were to write this properly, your solution set, so that's the squiggles, is 8 comma negative 3. If you wrote it like this, you would be saying that the answer is a coordinate 8 comma negative 3. So you would be implying that the x is 8 and the y is negative 3. Whereas if you write it with your squiggles, you're saying x equals 8 or negative 3. Okay. How do I stop